In the previous video, we saw the Game Genie in action, and we got to play with some codes and we got to modify a game. And of course, I'm talking about Pac-Man for Game Boy. We got our hands on some cheat codes that were available in the manual directly, and we input them, and we got the behavior of the game to change. And one thing that we modified was how many lives does Pac-Man have at the very start of the game. So, if you have keen eyes, you might have noticed some similarities between the codes. Here are the three codes that appear in the Game Genie manual. So this is the code that make Pac-Man start with 1 life. Not necessarily a cheat, just a modification that will make the game actually harder for you. But it is a code anyway. The second code make Pac-Man start with 6 lives, and the third code make Pac-Man start with 9 lives. So maybe you noticed already. There's a clear pattern here. And this is the pattern, 1, 6, and 9. This is part of the code, you see, clearly. The first two numbers of the Game Genie code that we input in the device are actually the number of lives that Pac-Man is going to start with. So we are one step closer to actually decoding how the Game Genie codes do work, okay? So how did the Game Genie codes work anyway? This is what we need to answer now. So what we know so far, let's just review. We know that invalid codes are rejected. I tried to make up my own codes. I tried to just input random numbers and they were rejected. Obviously, that's a security measure. We don't want the game to be breaking. And the code look very similar. Actually, it's just a number of lives that the only thing that's changing between the codes. That's the only difference, right? What is the Game Genie actually doing? Well, it intercepts ROM data. That's what it is doing. By no means is it changing the ROM. The ROM is read-only memory. It cannot be written upon. So this is just an interceptor. Whenever the DMG requests information from the ROM, it's going to intercept some of that information according to the codes that we input in the Game Genie, okay? So what does the Game Genie needs? It needs a value to write, the value that's going to be substituted with, needs a memory address, and something to verify that we are not just inventing a code, right? So let's try to decode one of those codes. Let's go for this code. This is the code that makes Pac-Man start with 9 lives, okay? So this is the code in its integrity. And just to make things simpler for us, I'm writing A, B, C, D, E, F, G, H, I to correspond to each of the values. I'll be using these letters as references when I start to decode what actually every number means, okay? So let's start with the very obvious. The value to write is AB, 09 in this case. And it's very clear for us to interpret that it is the number of lives that Pac-Man is going to start with, okay? This 9 is going to be written, well, not written, but actually substituted from a specific memory location. Believe it or not, the memory location is hiding in plain sight, but is a little bit scrambled. We just need to reshuffle the numbers a bit and we will get the memory location. This is the formula to get the memory location. The memory location, it's a reverse address. It starts with an offset of F000, and starting from that offset, you go up. So it means, in basic mathematic terms, we just need to subtract a value from F000 hexadecimal. What we need to subtract is F, C, D, E. So meaning F, C, D, and E. So you see F is F. It's coincidence, not a big deal. F, C, D, E, meaning FE25 in hexadecimal. from F000H, we subtract FE25H and we get 025H. This is the memory address, okay? This is the memory address where we are going to write this value. So now there's a check that needs to be performed. We need something to verify, okay? There's another piece of information that is hiding in plain sight, but it is a little more complicated to decipher. And this value is the value that is sitting right now at the ROM at this memory address, okay? We are going to substitute whatever is here with this value, but right now in the ROM, totally undisturbed, there is a value already sitting there, and this value is encoded in this number. Decoding this value, it's a little bit more complicated, but it's still simple. Remember that this was being done by a very simple computer. What might appear to be a complex mathematical function, it's actually a function that is very easy for this computer to actually manage. Without further ado, this is the formula, okay? We need to check previous value. So now we know what A, B, C, D, E, F stand for. So we're going to use GI, E6. E6 holds the value that is sitting right now in the ROM, totally undisturbed, but it is encoded, okay? So we need to do a little decoding. This is the formula to actually decode the value. So we need to grab GI, E6 in this case, and we need to perform these operations, okay? So don't freak out, it's actually very simple. There's an XOR operation inside, there's a rotate operation with a 2 as a parameter, so we need to perform 2 rotations, and an external XOR operation, okay? So let's start with the inside of the parentheses. First of all, let's do this operation GI XOR FF, okay? So GI, we already know what it is 6 in hexadecimal. We need to XOR with FF. If you open your calculator and you do this operation, you will get this number in binary, okay? And now we need to do a rotation, okay? So if I perform the rotate operation, this is what I get. Notice that the last 2 numbers actually jumped to the front of the number. This is what a rotation means, okay? We're actually shifting the bits 2 times, but instead of getting rid of the leftover bits, we are appending them to the beginning of the newly created number. So this is a rotation. We rotate the bits 2 times and we get this value, okay? So this is equal to 46. This is a binary encoding for 46 in hexadecimal, and we need to perform the final operation, which is an XOR operation with 45, a constant number. So if we do the XOR operation between 46 and 45, we get number 3. Does it make sense? Yes, it makes sense. With how many lives does Pac-Man start? With 3 lives, right? So this is the final decoding. So finally, that code means change the value at memory position 0E25 hexadecimal from 3 to 9. This is what this code actually is commanding the Game Genie to do, okay? 0E25H. Let's see this in action. So here's the dump of the ROM. We're inspecting all the memory. So if you hit Ctrl G, we can enter a memory location. So let's go to 0E25 and let's see what's in there. And here you go. And the number 3 is here. So everything is making sense. Modify code data, and I can modify it with 9. Okay, the modification has been done. This is a dump of the original cartridge. So if we start the game, you see, we can only see 6 here, but let's try with another number. Let's maybe modify this and let's enter a 5 or a 4. And there you go. 1, 2, 3. This is 0 base, so it means that it has 4 lives. If you don't believe me, we can actually change it to 5, and we will see that you have an extra life. There you go. There's an extra life. Okay. So everything's making sense, right? We know how to modify the number of lives as Pac-Man start. Oh, and just for the sake of completeness, remember the first cheat code was meant to just start with 1 life. And there we go, just 1 life, okay?